Hello, everyone. Our project's about understanding electrical consumption profiles, and we are Group 25 from Data Plus 2022.
So the whole idea behind non-intrusive load monitoring is that there's a sensor in people's houses that gathers their aggregate electricity use. We want to be able to use that to break down their usage into appliances, which can then be used to provide incentives, such as money for those who have been seen to use electrical car chargers and be more sustainable. Now, the idea sounds really nice in theory, but the question is it really possible? With various signals and various compositions, some which might look really similar, we delve into how and whether or not we can actually do this.
As noted previously, there is a need to efficiently and effectively control energy demand. There are two primary methods of doing so, intrusive load monitoring and non-intrusive load monitoring. Our focus is on non-intrusive load monitoring as it is low cost, with there only being one sensor for an aggregate load, thus more efficient. However, there are challenges concerning one's privacy, as a household's habits and practices can easily be identified by their energy usage. Additionally, its implementation is difficult as appliances can have similar signals, resulting in errors during the disaggregation process. Recurrent neural networks, LSTMs, bidirectional LSTMs, take advantage of recurrent mechanisms to identify temporal patterns and power consumption sequences. Recurrent layers utilize feedback connections to capture temporal information in memory and are well suited to sequential power, signal data, and energy disaggregation tasks. Our optimal model is a bidirectional LSTM, allowing for consideration of not only past instances, but also future ones. There is still a challenge with multi-class classification, as we're only able to identify if one appliance is on at a time rather than multiple.
After experimenting with numerous combinations of different appliances, the model managed to correctly describe the behavior of a given device on average 90% of the time. Another valuable insight was that the ratio between the magnitude of the noise present in the data and the magnitude of the signal itself is crucial for the quality of the predictions. In other words, reducing the noise in the curve through manufacturing better sensors, for example, would increase the accuracy of the model by a significant amount.
So moving forward, there are definitely a few things to tackle. First of all, we want to try and incorporate multiple components, which include not just current, and be able to classify multiple categories at once. Since now it's just binary, like whether one class is on or not, multi-class is the next step. Additionally, we want to be able to look into whether with this data and like how we know when people are using specific appliances, we can figure out whose house it's coming from. If we can, that's a privacy problem, and we need to go about fixing that. And finally, we need to look into more about the similar signals issue and like how we can break these down more properly and